Inside your left hand, right now, there are carbon atoms that should not exist. Every one was forged in a dying star, through a reaction that only works because a single nuclear energy level sits exactly where it needs to be. A coincidence so precise it was predicted backwards from the fact that you exist. Tonight, a theory holding 10 to the 500 universes, the worst prediction in the history of physics, and the fight over what your existence is allowed to prove. Start with the carbon. In 1953, a British astronomer walked into a nuclear physics laboratory at Caltech and made the strangest experimental request of the 20th century. His name was Fred Hoyle, the laboratory belonged to Willie Fowler, and Hoyle's demand was this. Somewhere in the carbon-12 nucleus, at almost exactly 7.65 million electron volts, there must exist an energy level nobody had ever seen. Fowler's team was skeptical. Theorists did not simply order nuclear resonances like sandwiches, and nothing in nuclear theory demanded one there. But Hoyle's reasoning was unlike anything in the textbooks. He was not arguing from nuclear physics at all. He was arguing from existence. Stars, he knew, must build carbon by fusing 3 helium nuclei, and when he ran the arithmetic, the reaction was too slow, catastrophically too slow, to account for the carbon that plainly fills the universe. The carbon in interstellar clouds, in planets, in the astronomer making the argument. Unless, and this was the leap, the carbon nucleus happened to have a resonance at just the right energy to catch the fleeting collision and amplify it enormously. Carbon exists, therefore the resonance exists. Go and find it. Fowler's group ran the experiment. Within months they had it. A state of carbon-12 at 7.65 million electron volts, within a whisker of Hoyle's demanded value. A nuclear fact deduced not from theory, but from the brute datum that the universe contains chemists. It remains one of the strangest successful predictions in the history of science, and it opened a door physics has never managed to close since. Because once you have seen one number on which your existence balances, you begin to notice the others. And the others are everywhere. Stop and look at the shape of what Hoyle did, because it is the strangest tool in tonight's kit, and the whole night runs on it. What kind of argument runs from chemists exist to a nuclear level sits at 7.65? It is not deduction from theory, the theory was silent. It is not induction from data, the data did not yet exist. It is selection logic. Whatever else is true, the universe we find ourselves in must be consistent with our finding ourselves in it. And that bare consistency requirement can, in the right hands, have teeth, sharp numerical teeth. The reasoning has a name now, the Anthropic principle, and it carries a reputation problem it has never shaken. To most physicists, it smells of circularity, of explaining the world by pointing at yourself. And yet there stands Hoyle's resonance, measured, real, found exactly where the pointing said to look. Is anthropic reasoning a legitimate instrument of discovery, or a parlor trick that got lucky once? Hold the question, because the largest version of it, applied not to one nuclear level but to every constant in physics at once, is precisely where this road ends. That door leads, by a road this night we'll walk in full, to the strangest large-scale proposal in modern physics, the string theory landscape. The idea, born from the mathematics of string theory, that the laws and constants of our universe are not the laws and constants, but one selection among a catalogue of possibilities so vast it defeats metaphor. 10 to the 500 distinct ways a universe can be, each with its own particle masses, its own forces, its own vacuum, almost all of them sterile, dark, and dead. On this picture, the numbers that permit your carbon are not deep truths inscribed in reality's foundation. They are local conditions, the weather of our particular cosmic address. And the reason the weather suits us is not that anything arranged it, but that in the unimaginable elsewhere, where it does not suit, there is no one to take the measurement. It is a proposal that has split physics at the spine. Its advocates include some of the deepest theorists alive, and it owns the single most startling quantitative success in this entire subject, a prediction made a decade early of the strangest number in the cosmos. Its critics call it the moment theoretical physics abandoned science itself. Tonight walks the whole road, the numbers that started it, the discovery that detonated it, the mathematics that houses it, the tests that have been tried, the rebels who reject it, and the honest, careful accounting of where it all stands. Keep your hand where you can see it. The carbon is not going anywhere, and by the end of tonight, you will know precisely how much and how little physics can say about why it is there. But before any theory gets the floor, the raw phenomenon deserves to be stated cold, because everything tonight, every camp, every equation, every fight, begins from one shared observation that no one on any side disputes. The laws of our universe are startlingly sensitive to their own dials. Physics, as currently written, contains a couple dozen pure numbers that the equations do not fix. They are measured, not derived. The strength of the electromagnetic force, the masses of the elementary particles, the relative strength of gravity, the energy density of empty space. Nothing known forbids those numbers from being otherwise, and yet, run the thought experiment of turning any dial, and the consequences cascade with shocking violence. This is not a claim about meaning, it is a claim about arithmetic, checkable line by line. And the first stop on that arithmetic tour is the number Hoyle found, because 70 years of nuclear physics since 1953 have measured exactly how narrow his window really is.
Here is the modern anatomy of Hoyle's coincidence with current numbers.
Inside a red giant star, helium nuclei collide constantly, but two helium nuclei make beryllium-8, a nucleus so unstable it falls apart in 1/10 of a quadrillionth of a second. For carbon to form, a third helium nucleus must strike that evaporating target within its unthinkably brief lifetime. A triple collision, an intrinsically desperate long shot. What rescues it is Hoyle's state, the carbon-12 resonance, measured today at 7.654 million electron volts, sitting 379 kilo-electron volts above the combined energy of the three colliding heliums. Close enough that the collision pours directly into the resonance, which catches it the way a tuned string catches a matching note. The night's first equation prices the sensitivity, and it is short. Before the symbols, the carbon production rate depends exponentially on the gap between the resonance and the collision energy. The equation reads rate proportional to gamma times e to the minus epsilon over kt. Epsilon is that 379 kilovolt gap. T is the star's temperature, and the exponential is the tyrant. The modern analyses conclude the resonance boosts carbon production by a factor of 10 to 100 million. And that shifting epsilon by even 100 kilovolts, a few percent of the state's energy, begins to strangle the carbon-to-oxygen balance on which chemistry as we know it runs. One nuclear level placed within a few percent. Every organic molecule in the universe rides through that gate. What do you do with a fact like that? Be careful, because what you do with it is the entire remaining subject of tonight. Linger inside the star one moment longer, because the carbon story has a second act that doubles its strangeness. Having made carbon through Hoyle's gate, the star immediately threatens to unmake it. The next fusion step, carbon capturing another helium to become oxygen, runs in the same furnace. If that second reaction also enjoyed a perfectly placed resonance, it would run to completion, and the universe would hold abundant oxygen and almost no carbon, chemistry's foundation consumed as fast as it formed. It does not. The relevant oxygen level sits just below the threshold, close enough to help the reaction along, far enough to keep it from devouring the carbon supply. The cosmos threads the needle twice, in opposite directions, in the same stellar core. One resonance place to make carbon possible, a second place to leave some carbon behind. Physicists who model these chains report that the carbon-to-oxygen balance, the ratio your biochemistry runs on, survives only within a narrow corridor of nuclear parameters. Two doors, both ajar at the required angles. That is the texture of the phenomenon tonight keeps in view, not one lucky number, but chains of them, interlocking, each checkable, none explained. And the carbon gate is only the most famous doorway in a corridor of them. Nudge the strong nuclear force a few percent stronger, and the runaway fusion chemistry of the early universe changes character. A few percent weaker, and heavy nuclei struggle to hold together at all. Shift the balance between the electron's mass and the nuclear masses, and the delicate structures of chemistry blur. Strengthen gravity relative to electromagnetism by a few orders of magnitude, and stars shrink into short-lived furnaces that burn out before planets settle. The literature cataloguing these sensitivities is large, technical, and, honesty demands the report, actively contested in both directions. Physicists like Fred Adams have pushed back against the more breathless accounting, arguing that if you vary several constants together rather than one at a time, the region of parameter space that still makes working stars is not a pinprick, but something like a quarter of the map. The cosmos, on his analysis, is more forgiving than the folklore claims, though his figure has its own critics in turn. Keep that dispute in view as tonight's first honesty anchor. The raw sensitivity of our physics to its dials is established arithmetic. The degree of specialness, how narrow the habitable target really is, measured properly, is an open research question, not a settled marvel. What no one disputes is the phenomenon itself. The equations of physics, as written, contain unexplained numbers, and the living world depends on their values with an intimacy that physics did not expect and has never explained. School taught you those constants as if they were logical necessities. They are not. They are measurements, and nothing in known science says why they measure what they measure. Bring the dials into your kitchen for a moment, because abstraction hides how strange this inventory is. Imagine the constants of physics as an actual control panel on your wall. 24 knobs, labeled in a language you can read: gravity's strength, the electron's mass, the vacuum's energy. The panel controls everything. The knobs were set before you arrived, and nothing printed on the panel explains the settings. Would you dare touch one? Twist the electromagnetic knob a few percent and watch stellar chemistry lurch. Brush the vacuum knob by 1 part in 100 billion trillion, and the universe empties itself before chemistry begins. Now the question that should genuinely unsettle you: who or what does the panel answer to? Not who set the knobs, strike the loaded framing, but the physics version. Is there a lock under the panel, a deeper mechanism that only permits these settings? Or does the panel float free, its settings varying from cosmic region to cosmic region, with us necessarily downstream of a survivable configuration? What does it mean that after 4 centuries of triumphant physics, the honest answer to why does the panel read what it reads is nobody knows? Notice what this phenomenon is not, because tonight's precision depends on drawing the line early and holding it. The sensitivity of chemistry to the constants is physics, computable, checkable, published. Any conclusion about why the constants sit where they sit is not yet physics. It is one of 3 live conjectures, and every voice in tonight's story belongs to one of them. Conjecture 1. Necessity. There exists a deeper law, not yet found, that fixes the constants uniquely. The dials only look adjustable because we have not found the mechanism that welds them. This was Einstein's instinct, and Hoyle's, and it remains the quiet hope of much of physics. Conjecture 2. Selection. The constants vary across an enormous ensemble of regions or universes, and observers necessarily sample only the values compatible with observers. The appearance of a cosmos fitted to us is what survivorship looks like from the inside. Conjecture 3. Brute fact. The constants simply are what they are, uncaused and unexplained, and the demand for a reason is a category error. Physics cannot currently eliminate any of the 3, and tonight will not pretend otherwise. What tonight can do is follow the second conjecture, Selection, because it alone, in the last 40 years, grew from armchair speculation into a detailed physical framework with mathematics, mechanisms, and one genuine predictive scalp on its belt. That growth is the story of the landscape, and it begins, of all places, with the most boring-sounding object in physics: empty space. If you find value in walks like this one, taken carefully, consider subscribing. It helps these deep dives reach more curious minds. Because the deepest dial of all, the one that detonated this entire subject, turned out not to be the strength of a force or the mass of a particle. It is the energy of nothing. Take a box, remove every particle, every atom, every photon. Shield it from every field. Cool it to absolute zero. What remains, pure vacuum, should, by your instincts, weigh nothing and do nothing. Quantum field theory disagrees violently. In its accounting, the vacuum seethes. Every field of nature fluctuates ceaselessly even in its emptiest state, and those fluctuations carry energy. And when physicists tally the vacuum's energy budget, the zero-point contributions of every field, integrated to the theory's limits, the number that emerges is not merely large. It is the most catastrophically wrong number in the history of science. The capital Lambda at the center of this chapter has the strangest biography of any symbol in physics, and 30 seconds of it pays dividends all night. Einstein added it to his equations in 1917 for a reason that embarrasses in hindsight. His relativity insisted the universe must expand or contract, the astronomy of the day insisted it did neither, and lambda was the patch, a repulsive term tuned to hold the cosmos static. 12 years later, Hubble found the expansion, the patch became pointless, and Einstein reportedly rued the whole episode. The term spent decades as a cautionary tale, set to zero in every respectable model. Then the 20th century closed by handing the discarded symbol the largest role in cosmology. The dominant component of the universe, resurrected by supernova data, wearing the name dark energy. A term invented for the wrong reason, abandoned as a blunder, and returned as the main character. Lambda's biography is tonight's warning label. In this subject, even the mistakes outlive the certainties that condemned them. The mismatch is worth savoring digit by digit because nothing else in science compares. Quantum field theory's naive estimate of the vacuum's energy density overshoots the value actually observed in the cosmos by up to 120 orders of magnitude. Not 120 times too big, 10 to the 120 times too big. A 1 followed by 120 zeros. Physicists, a profession not given to superlatives, call it in print the worst theoretical prediction in the history of physics. One writer's translation: it is as if your best theory calculated that a 5-pound bag of flour should weigh 5 pounds, with 120 extra zeros after the 5. If the vacuum actually carried the energy the calculation suggests, the consequences would not be subtle. Space itself would curve violently at every point, expansion would run away instantly, and no atom, star, or observer could ever assemble. The universe would be over before it began, everywhere, always. The plain fact that you are sitting somewhere reading a screen, that space is calm enough to cross a room, is a measurement, and what it measures is that the true energy of the vacuum is almost unfathomably smaller than our best theory can explain. Almost, but not quite, zero. And it is the not quite that turns this from an embarrassment into a detonator. How does a serious science miss by 120 orders of magnitude? The anatomy of the error is worth one careful minute, because it is not carelessness. It is two magnificent theories disagreeing about the same room. Quantum field theory says every field fluctuates at every point of space, down to the smallest scales the theory reaches, and each fluctuation deposits energy. Sum the deposits and the vacuum's density comes out enormous, Planck scale enormous if the sum runs to the theory's natural limit. General relativity says energy, all energy, including the vacuums, bends spacetime and drives expansion. Each theory is confirmed to exquisite precision on its own turf. Put them in the same sentence. How much does quantum nothing gravitate? And the answer misses observation by up to 10 to the 120. Could the fluctuations somehow not gravitate? Then general relativity's core principle fails. Could they cancel? Then something must enforce the cancellation to 120 decimal places, and nothing known does. The mismatch is not a bug in one calculation. It is the two pillars of physics grinding against each other at the exact point where they meet, which is why the smallness of the vacuum's energy is held by many to be the deepest single clue our era possesses about the physics still to be found. Because for most of a century, physics had a fallback position. Perhaps some undiscovered symmetry simply forces the vacuum's energy to cancel, every positive contribution matched by a negative one, the total pinned to exactly zero by deep principle. Zero is a natural number for a law to produce. Theorists know how to build mechanisms that yield zero. The fallback was comfortable, widely assumed, and quietly held for decades, while the actual measurement remained out of reach. Here is the number that destroyed it. The vacuum energy, the cosmological constant, the capital lambda that Einstein first scribbled into his equations in 1917 and later repudiated, has now been measured. And its value, expressed in physics' most natural units, the Planck units built from the constants of nature themselves, is roughly 2.8 times 10 to the minus 122. Absorb the shape of that number. A decimal point, then 121 zeros, then finally a digit. Not zero, 121 zeros and then something. No symmetry principle anyone has ever constructed produces a number like that. Symmetries produce zeros, not near misses fine beyond all reason. The value is at once absurdly small, small past every explanation, and stubbornly, measurably non-zero, and that combination is the deepest single why in modern physics. Why is the energy of nothing not enormous as calculated? Why is it not exactly zero as hoped? Why is it this, a whisper, 121 zeros deep, precisely faint enough to leave room for everything else? What does it mean that the most precisely wrong prediction in science and the most inexplicably placed number in science are the same number? Hold the timeline carefully now, because the order of events is the whole drama of the next two chapters. The measurement of that number, the discovery that the vacuum's energy is real, positive, and tiny, arrived in 1998, and it stunned the field. But 11 years earlier, in 1987, when nearly every cosmologist on Earth assumed the cosmological constant was exactly zero, and the measurement seemed forever out of reach, one physicist sat down and computed what its value ought to be, using a form of reasoning most of his colleagues regarded as barely legitimate. His prediction was on the record, in Physical Review letters, a decade before the observation. He reasoned not from a deeper law, not from a new symmetry, not from any mechanism at all, but from the same scandalous direction Fred Hoyle had aimed at the carbon nucleus 34 years earlier. He reasoned from the fact that anyone exists to ask. His name was Steven Weinberg, Nobel laureate, architect of the Standard Model, and by wide agreement one of the most rigorous minds physics has ever produced. Which is exactly what made what he did next so unsettling to his profession. Understand first why the move Weinberg was about to make was professionally radioactive, because the context is half the story. By 1987, anthropic reasoning had spent 2 decades as physics' unwelcome guest, invoked in after-dinner speculation, banished from serious journals, regarded by the mainstream as the abandonment of explanation itself. The objections were, and are, serious. It explains by selection what physics is supposed to explain by mechanism. It risks unfalsifiability. What observation could ever contradict "things are as they must be for us to see them"? And it invites laziness. Every unexplained number can be shrugged into anthropics instead of solved. Respected careers had been dented by less. So ask the question the era asked. What could drive the most rigorous theorist of his generation, the man whose standard model papers are monuments of calculational discipline, to pick up the one tool his profession despised? The answer is the number itself. The vacuum energy had defeated every respectable tool. Symmetries failed. Mechanisms failed. Dimensional analysis missed by 120 orders. When every legitimate instrument returns nothing, a rigorous mind faces a choice: declare the problem premature, or check carefully whether the illegitimate instrument has teeth. Weinberg checked. What Weinberg did in 1987 was ask a question with an if in it, and then have the discipline to follow the if wherever it led. Suppose, he said, the cosmological constant is not fixed by any law. Suppose its value varies, from place to place, from region to region, across some vast ensemble of cosmic domains, whatever their origin. Then asking, why do we measure this value, becomes a different kind of question. The way asking, why does our planet have liquid water, changed the day astronomers realized planets are plentiful. Nobody invokes a deep law of hydrology to explain Earth's oceans. Among billions of worlds, some fraction happen to orbit at the right distance, and creatures made of liquid chemistry necessarily wake up on those. Weinberg applied the same survivorship logic to the vacuum itself, and then, crucially, he made it quantitative. The key is that the cosmological constant is not a passive backdrop. It actively sabotages structure. A positive vacuum energy accelerates cosmic expansion, and expansion is the enemy of gravity's slow work of gathering matter into galaxies. Run the competition carefully, as he did. If the vacuum energy is too large, expansion wins early. Matter is flung apart before gravity can collect it. No galaxies condense, no stars ignite, no chemistry, no observers, nobody home to measure anything. From the requirement that galaxies manage to form at all, Weinberg derived a ceiling, the largest value of the cosmological constant any observer could ever find themselves under. The Knight's second equation is that bound in its essence. Before the symbols, the vacuum's energy density can be at most a few hundred times the average density of matter in the era of galaxy formation. The equation reads, ρ lambda at most, roughly 550 times ρ naught. In natural units, that ceiling comes out around 10 to the minus 121. And here is the move that separated Weinberg from every armchair philosopher who had ever waved at such reasoning. He drew a conclusion that could fail. If this survivorship logic is what fixes the value, he noted, then there is no reason for the constant to sit at exactly zero. A typical observer in the ensemble should measure a value comparable to the ceiling, small but not vanishing. At a time when the professional consensus said the constant was zero and the measurement was impossible, Weinberg's reasoning said, non-zero, near the bound, and, implicitly, measurable, someday, if anyone could weigh the universe's expansion precisely enough. The paper's reception measured the profession's discomfort precisely. Respectful citation, minimal adoption, and a decade of quiet. The bound was checked, acknowledged as sound, and treated as a curiosity, because accepting its premise meant accepting the ensemble, and no respectable physics of the era contained one. The consensus position remained that the cosmological constant was exactly zero for a reason not yet found, and that Weinberg's window, non-zero, near the ceiling, was an elegant deduction from a premise nobody believed. Ask what would change that standing, and the answer was obvious to everyone: a measurement. If the constant proved exactly zero, the anthropic argument was dead weight. Survivorship gives no reason for exact zero. Some undiscovered symmetry would be the winner. If the constant proved non-zero and near the window, the specific, unfashionable, on-the-record expectation of the survivorship logic, the despised argument would hold the only successful prediction in the field. The 1990s opened with the question genuinely undecided and almost universally expected to break against Weinberg. Physics does not often arrange so clean a wager between its instincts and its outsider.
11 years later, someone could. Two rival teams, the Supernova Cosmology project under Saul Perlmutter and the High-Z Supernova search team of Brian Schmidt and Adam Rees, spent the 1990s racing to measure the deceleration of the universe. Deceleration, that was the entire framing. Whatever the universe's long-term future, everyone knew the expansion must be slowing, dragged by the gravity of everything in it. The teams merely disputed how much. Their tool was a species of exploding star, Type 1a supernovae, white dwarfs that detonate at a uniform intrinsic brightness, making them standard candles visible across billions of light-years. Measure how faint one appears, and you know how far away it is. Measure its redshift, and you know how fast the cosmos has stretched since its light departed. Chart enough of them at enough depths, and the universe's expansion history falls out. Both teams charted, cross-checked, fought their own data, and in 1998 both arrived, reluctantly and independently, at the same impossible result. The distant supernovae were too faint. The expansion was not slowing, it was speeding up. Some pervasive influence, promptly named dark energy, and behaving in every measured respect like Einstein's discarded cosmological constant, was pressing the universe apart, and it dominated. The best modern accounting, from the Planck satellite's final release, assigns it 68% of everything that exists, with dark matter at 27% and ordinary atoms, every star, every planet, every person, under 5%. The discovery earned the 2011 Nobel Prize and rewrote cosmology's ending. A universe not coasting to a halt, but accelerating into ever emptier cold. And sitting quietly inside the triumph was the number. The measured value of the vacuum's energy, that 2.8 times 10 to the minus 122, landed roughly 2 orders of magnitude below Weinberg's Anthropic ceiling. Comfortably within his window, squarely in the range his survivorship logic had marked out a decade in advance, and flatly non-zero in defiance of the era's consensus. The one prediction on the books had come from the one style of reasoning physics had always refused to admit through the front door. Now, precision, because this is one of the most misquoted episodes in modern science, and tonight's credibility rides on stating it exactly. Weinberg's success is real. It is the only quantitatively successful advanced prediction of the cosmological constant scale ever made, and every physicist in this story, on every side, concedes the fact. And Weinberg's success proves far less than the enthusiasts claim. A survivorship argument predicting the value correctly does not demonstrate that an ensemble exists. It demonstrates that if one exists, our value is unsurprising. The logic's own author flagged the limits in the original paper, noting soberly the conditions under which anthropic considerations would explain nothing at all. A single successful post-diction-style hit, however striking, can be coincidence. The deeper law that conjecture, one hopes for, could equally well produce a small, non-zero value for reasons not yet imagined. What the 1998 measurement actually did was sharpen the dilemma to a razor. The most important number in physics is one that our best theory miscalculates by up to 120 orders of magnitude, that no known principle fixes, and that the only successful prediction of treats our universe as a sample drawn from an enormous unseen population. Physics was left holding a question it could no longer put down. A sample, drawn from what? If the survivorship logic is to be more than a lucky guess, there must actually be an ensemble, a real, physical collection of regions with different vacuum energies, generated by real mechanisms, housed in a real theory. Within 5 years of the supernova result, theorists believed they had found exactly that. Not constructed for the job, hold that thought, but lying in wait, unwelcome,
inside the most ambitious theory physics has ever attempted. String theory entered the 1990s as physics' best hope for a final theory, a single mathematical structure from which, its pioneers hoped, every constant of nature would one day be derived uniquely. One theory, one universe, every dial welded in place by consistency alone. That was the dream Einstein would have recognized, and it is essential to tonight's honesty to remember that the landscape was not what string theorists wanted. It was what the mathematics forced on them. The theory's foundation is that reality's basic objects are not point particles but tiny vibrating strings, and its unbending structural demand is that space-time have 10 dimensions. We observe 4. The remaining 6, the theory holds, are compactified, curled into a shape so small no experiment resolves it, a 6-dimensional knot the geometers call the favored family Calabi-Yau manifolds, tucked invisibly into every point of the space you move through. And here the dream met its complication. The knot's shape is not unique. The 6 hidden dimensions can be folded into a bewildering variety of topologies, different numbers of holes, handles, and internal cycles. And every distinct folding produces different observable physics, because the vibrating strings take their marching orders from the geometry they wrap. The particle masses we measure, the forces we feel, the constants in our textbooks, all of them, in string theory, are echoes of the hidden shape. Change the fold, change the physics. The catalogue of possible universes had entered through the geometry, and geometry was only the beginning. Where exactly are these 6 extra dimensions supposed to be? Not far away. That is the misconception the picture always invites. If string theory is right, they are here, curled at every point of the space in this room, at every point of your body, a knot of hidden geometry smaller than any probe can resolve, repeated everywhere the way a carpet's weave is repeated under every footstep. You do not travel to them, you are threaded through them at all times, and the physics you experience, which particles exist for you, how strongly they pull, is the sound the strings make vibrating in that hidden weave. Ask why you cannot see them, and the answer is scale. The folds are expected near the Planck length, 10 to the 19 times smaller than anything the greatest collider resolves. Ask how physicists dare theorize about geometry no instrument reaches, and the honest answer is the one this channel always gives: consistency. The mathematics permits only certain shapes. Plus consequence, different shapes yield different low-energy physics, which is exactly the property that turns hidden geometry into tonight's engine of variety. The weave is invisible. The catalogue of possible weaves is not even close to invisible. It is the largest number in this story. Because the folds can also be threaded, string theory contains generalized field strengths, fluxes, that can wrap the internal cycles of the compact shape like current wrapping a coil, and a deep quantum rule forces each wrapping to come in whole number units: 1 unit, 2, 17, 300, never fractions. In 2000, Raphael Bousso and Joseph Polchinski realized what integer-valued fluxes threading hundreds of independent cycles imply for the vacuum's energy. Each flux contributes to the total. Each can take many integer values, and the number of distinct combinations explodes combinatorially. Their result, the Knight's third equation in its essential shape, counts the possibilities. Before the symbols, the number of vacua scales like the flux bound raised to the power of the number of flux directions. The equation reads, n of vacua, roughly, 2 pi L to the k, over k factorial, with k, the number of independent flux directions, running to several hundred for realistic foldings. Run modest numbers through that innocent formula and it detonates. With a few hundred directions and generous bounds, the count of distinct vacuum states lands, heuristically, near 10 to the 500. The figure, sharpened by the counting techniques of Sujay Ashok and Michael Douglas, is an estimate, not a census. Specialists argue its derivation and even its meaningfulness. But no serious analysis brings the count down to anything tame. For comparison,
the observable universe contains roughly 10 to the 80 atoms. The catalogue of possible universes inside string theory outnumbers the atoms in this one by 420 orders of magnitude. And each entry in the catalogue, each choice of folding and flux, is a complete specification of a possible physics. Its own particle roster, its own forces, its own cosmological constant, scattered across the entries in steps so fine that somewhere in the catalogue, inevitably, sit values as absurdly small as 2.8 times 10 to the minus 122. The discretuum, Busso and Polchinski called it, a spectrum of possible vacuum energies so dense it mimics a continuum, and with it, for the first time, the cosmological constant's insane smallness stopped being unrepresentable, not explained. Representable, the catalogue has an entry for it. 3 years later came the paper that turned the catalogue from bookkeeping into cosmology's most contested real estate. In 2003, Shamit Katru, Renata Kalosh, Andre Linde and Sandeep Trivedi, the initials KKLT are now a permanent fixture of the field, published a construction recipe for such vacua that addressed the hard part, stability. A catalogue entry is worthless if the universe it describes instantly collapses or unravels. The hidden dimensions' size and shape are themselves dynamical quantities, moduli, that must be pinned in place or the whole geometry slumps. KKLT's two-step recipe, stabilize the moduli with fluxes and subtle quantum effects, then lift the result to a state with small positive vacuum energy, produced, on paper, exactly what our universe appears to be, a metastable pocket with a tiny positive cosmological constant. Metastable. Hold that word for the final act, because it means not permanent, and it will come back twice, once as a threat and once as a clue. Understand who it was that then said the unsayable, because the messenger is half the message. Leonard Susskind is not a fringe figure borrowing string theory's prestige. He is one of the theory's inventors, present at its 1969 birth, architect of foundational results across 5 decades, a physicist whose conservative credentials in the field could not be higher. And the community he addressed in 2003 was a community in quiet crisis about exactly this. The theory built to derive the universe uniquely had instead disgorged a catalogue, and most practitioners were treating the catalogue as an embarrassment to be engineered away, a temporary surplus that better mathematics would prune to one. The essay that named the landscape did the opposite. It proposed that the surplus is the discovery, and that same year, Susskind published the essay that named the whole picture and lit the fuse. Surveying the exploding catalogue, he argued that string theory's vast space of vacua should be taken seriously as a landscape, his word, of genuinely existing possibilities, and he drew the conclusion the community had been circling for years without daring to print. It seems plausible, he wrote, that the landscape is unimaginably large and diverse. Whether we like it or not, this is the kind of behavior that gives credence to the anthropic principle. Whether we like it or not, from one of the theory's own founders. The final theory's catalogue had become, in its architect's hands, the ensemble Weinberg's argument was waiting for. All it needed now was a delivery mechanism, something to take the catalogue's entries off the page and make them physically real somewhere. Cosmology, it turned out, had been holding exactly that mechanism for 20 years, and it runs on the most violent process ever proposed in physics. The mechanism is eternal inflation, and it grows from the same theory that explains why our universe is so smooth. Inflation, the proposal built by Alan Guth, Andre Linde and others, that the infant universe underwent a burst of exponential expansion, solves textbook cosmology's deepest puzzles and has passed every observational audit the microwave sky can offer. But the theory carries a wild rider that its own founders uncovered within years. Generically, inflation does not know how to stop. The inflating state is self-sustaining, space multiplying faster than it decays, so while inflation ends locally, in patches, the larger inflating volume keeps growing without limit. Each patch where it ends becomes a pocket universe, a bubble of ordinary slow expansion, condensing out of the inflating storm like a droplet in a cloud bank, while the storm rages on without end around and between the droplets, nucleating new pockets forever. And the physics governing each droplet's birth is the night's fourth equation, worked out by Sidney Coleman and Frank DeLucia back in 1980, before anyone knew what it would be for. Before the symbols, a region trapped in one vacuum can quantum tunnel to a deeper one, and the rate is exponentially suppressed by the energy barrier between them. The equation reads gamma equals A times e to the minus s. Gamma is the rate at which bubbles of new vacuum nucleate. S is the action of the tunneling path. And the mechanism is the landscape's delivery service. A pocket born in one entry of the catalogue can tunnel, locally by bubble, into neighbouring entries. Each bubble inflates into its own cosmos with its own constants, and given unlimited time, the storm executes an unbounded random walk across the catalogue. Weld the pieces, a catalogue of 10 to the 500 possible physics, string theory's landscape. A generator that physically instantiates entries without limit, eternal inflation. And a filter, Weinberg's survivorship, selecting which pockets contain anyone to take measurements. That triple assembly is the Anthropic multiverse, the mainstream, load-bearing version of the claim in tonight's title. On this picture, the carbon resonance, the constant's narrow tolerances, the vacuum's 121.0 whisper, none of it is deep truth about reality's foundations. It is real estate. We live where living is possible, in the one kind of neighborhood that produces residents, and the apparent fit between the neighborhood and its residents is a selection effect with no more mystery, on this view, than the fact that every fish you ever meet lives in water. Give the ensemble its texture, because other universes undersells what the catalogue actually varies. Neighbouring pockets on this picture are not our universe with different weather, they differ in the cast of particles itself. A pocket whose folding yields no light quarks has no protons, no atoms, no chemistry. A cosmos of exotic matter cooling into permanent structurelessness. A pocket with a vacuum energy a few steps up the discretium blows itself smooth before the first gravitational clump can form. A perfect thinning gas, forever. Pockets with stronger gravity burn through their stellar fuel in geological instants. Pockets with different force balances never ignite stars at all. Run the catalogue statistics and the overwhelming majority of entries are, by any biochemical standard, dead on arrival, which is precisely what gives the survivorship filter its cutting power, and precisely what the title of tonight's video is pointing at. If the landscape is real, habitability is not the norm with exceptions. It is the exception, vanishingly rare, an archipelago of a few live addresses scattered through 10 to the 500 vacancies. Test the assembly's logic against the pushback it always earns, because the fish analogy hides a real dispute. Every fish lives in water, granted. No one explains a particular fish's wet surroundings by deep lore. But a philosopher fish could still ask a question the survivorship shrug does not touch. Why does the ocean exist at all? Survivorship explains why observers find habitable conditions, given that both habitable and uninhabitable regions exist. It does not explain why the ensemble exists, why it samples the possibilities broadly enough to include habitability, or why there is anything rather than nothing to select from. The landscape answers the first question and inherits the others. String theory must be true, eternal inflation must run, and the catalogue must be broad. Each a premise, none observed. Is that progress? Genuinely, arguably, yes. Trading one inexplicable number for a package of testable in principle structural claims is how science often advances. And genuinely, arguably, no. Critics say it trades a sharp question for a picture whose premises are conveniently unreachable.
Both verdicts live in the professional literature. What does it mean that physics' best answer to its hardest number begins by multiplying the universe 10 to the 500-fold, and that no one can say, even in principle, whether the multiplication happened? Feel the philosophical ground shift under that assembly, because whatever its truth, it is one of the great inversions in the history of ideas. Every earlier era of physics treated the constants of nature as the deepest layer of explanation. The bedrock the universe is built from, the numbers a final theory would derive. The landscape picture demotes them to environmental facts. Not laws, but local weather, no more fundamental than the temperature of your hometown, and exactly as much in need of cosmic explanation. The question, why is the vacuum energy 10 to the minus 122, receives the same answer as, why is Earth 93 million miles from the Sun? It isn't, mostly. You just live in one of the rare places where it is. And notice, tonight's precision demands it, what this inversion buys and what it quietly spends. It buys an answer to the fine balance phenomenon that invokes no new principle and no unknown mechanism. Nothing beyond large numbers and survivorship, the same statistical reasoning that demystified Earth's oceans. It spends, in exchange, something physics has never before agreed to spend: the ambition of uniqueness. If the landscape is right, the final theory will never derive the electron's mass, because the electron's mass is not derivable. It is an address. Generations of physicists entered the field on the promise of computing the constants from first principles. The landscape tells them the constants are, in the deepest sense, not computable but locational. Is that an explanation or an abdication dressed as one? That question, in exactly those words, is what the war of the next chapters is fought over. What does it mean for the oldest project in physics when its best current framework concludes that the numbers it swore to explain are, forever, weather? And one more honest weight goes on the scale before the tests begin, because the delivery mechanism carries a sting its enthusiasts cannot remove. Everything it delivers is, by construction, out of reach. The pockets of eternal inflation are separated by inflating space that expands faster than any light signal can cross it. Other bubbles are not merely far away, like undiscovered islands, they are causally severed. No telescope, no probe, no signal, ever, even in principle, under the picture's own physics. The ensemble that would explain our constants is an ensemble the explanation itself forbids us from inspecting. With a single possible exception. If, in the storm's early violence, another bubble had collided with ours, a glancing impact in the first instance before inflation carried the wreckage beyond the horizon, the bruise would still be printed on the oldest light in the sky, a faint disk of anomalous temperature in the cosmic microwave background, with a specific, computable profile. One conceivable fingerprint on one observable sky. And in 2011, a team of cosmologists went looking for it, with an algorithm, a map of the infant universe, and no idea whether they wanted to find something or not. The team, Stephen Feeney, Matthew Johnson, Daniel Mortlock, and Hiranya Piris, did the thing this channel honors above all. They took the most metaphysical-sounding proposal in science and treated it as data analysis. If an ancient bubble collision bruised our cosmos, the mark has a predicted shape. A disk on the sky, azimuthally symmetric, with a temperature profile falling off in a specific, computable way. Nothing like the random mottling of ordinary cosmic structure. So they built an algorithm with no allegiance, a blind pattern search, calibrated on simulated skies, built to flag disk-like anomalies in the WMAP satellite's map of the microwave background, and score each candidate against two rival explanations: bubble bruise or ordinary Gaussian fluctuation that happens to look round. Then they released it on the real sky. The result, published in 2011, is a small masterpiece of scientific temperament. The algorithm flagged 4 features, 4 patches of the infant universe better fit, locally, by the collision profile than by standard fluctuations. 4 candidate bruises.
and the team's own verdict, delivered in the same breath, not significant. Not one feature rose beyond the level that random chance should produce on a sky this large. The collective evidence favored no detection, and the honest deliverable was a bound, at most a few collision signatures on the visible sky, with the data fully consistent with zero. Johnson put the finding with a care-tonight quotes verbatim. While we didn't make any clear detections, we did find 4 features better explained by the bubble collision hypothesis than by the standard one. Pieris. These first results are not conclusive enough either to rule out the multiverse or to definitively detect the imprint of a bubble collision. And Mortlock, with the deadpan this subject deserves, it's all too easy to overinterpret interesting patterns in random data, like the face on Mars that, viewed more closely, turned out to be just a normal mountain. 4 maybes, honestly labelled, on the only observable the entire multiverse framework has ever offered. Sit for a moment with the poignancy of the one sky problem, because it is unique in science. Every other field can gather more evidence, more fossils, more patients, more collisions, more stars. Cosmology's largest questions are asked of a sample of exactly one observable universe, one microwave sky, its grandest patterns drawn once, in a lottery whose other tickets no one will ever see. When the bubble hunters report 4 features non-significant, the phrase "not significant" carries a permanence it carries nowhere else. Not gather more data, but there is no more data of this kind, ever. Would the features look significant with 10 skies to compare? Nobody will ever know. And that sentence is not defeatism, but geometry. What does it mean to practice science at the one scale where the universe declines permanently to repeat the experiment? Absorb what that episode actually established, because both its friends and its enemies routinely misreport it. It did not find the multiverse. The authors said so in every venue available. It did not refute the multiverse. Absence of collisions is exactly what the framework predicts in the overwhelmingly likely case that no bubble struck ours within the observable window. What it established is that the question can, in one narrow channel, be asked scientifically at all. That do other universes exist possesses, against every philosophical expectation, at least one falsifiable edge. And it simultaneously established how thin that edge is. The searches have been extended and sharpened since. The tally stands unchanged. Candidate features, none significant, bounds consistent with zero. Meanwhile, the boundary conditions of the hunt are fixed by physics itself and cannot be engineered around. The microwave sky is one sky, a single sample of the largest scales, cosmically variance limited, meaning the statistics of the biggest patterns can never improve because there is exactly one observable universe to measure and no second sky to average against. The last scattering surface is a wall. No photon from before the universe turned transparent can ever be imaged, and anything beyond our horizon is dark forever by geometry, not by budget. Astronomy's entire history is a story of better instruments dissolving every wall it met. And this wall is different in kind. Not an engineering frontier, but a causal one. What does it mean for a scientific hypothesis when nature itself guarantees that 99.99, and then many more nines, % of its subject matter is unobservable in principle, forever? And be precise about what falsifiability does and does not demand, because the coming fight turns on it. The rule of thumb, a scientific theory must be able to fail, is a philosopher's compression of scientific practice, not a law with a court. Plenty of respectable science leans on unobservables. Quarks are never seen singly. The universe beyond the horizon is inferred, not imaged. Nobody demands a laboratory supernova. The honest question is never, is every part observable, but does the framework as a whole stake anything on the world? The multiverse's defenders answer yes. It staked Weinberg's window and won. Its structure could have been incompatible with a small constant and was not. Its critics answer that one retrospectively framed success, purchasable by multiple frameworks, is too thin a stake for so vast a claim, and that a picture which can absorb any observation somewhere in its 10 to the 500 entries has, in practice, stopped betting. Both positions are defensible. Neither is silly. Keep that calibration as the shouting starts. That question is not rhetorical, and physics establishment has answered it in public in both directions with a vehemence rare in the professional literature. Because if the bubble hunt is the multiverse's one thin empirical edge, everything else about it must be judged on theoretical virtue, internal consistency, explanatory power, the Weinberg hit, and on whether those virtues are enough to call a thing science. In December 2014, the journal Nature published a broadside from two eminent scientists, the cosmologist George Ellis and the astrophysicist Joe Silk, under a title that was itself a declaration: Defend the Integrity of Physics. Their target was explicit: multiverse cosmology and the string landscape, and the philosophical drift they saw carrying physics toward accepting elegant, untestable frameworks as established truth. Their words were unsparing. Attempts to exempt speculative theories of the universe from experimental verification, they wrote, undermine science. A theory that can accommodate any observation, that predicts everything somewhere and therefore nothing in particular, that concedes its own subject matter is causally unreachable, such a theory, they argued, has stepped outside the tradition that gave physics its authority, and the community that embraces it is spending credibility it may not recover. The riposte from Susskind's camp and others was equally direct. Falsifiability is a philosopher's rule of thumb, not a law of nature. The landscape is not a free invention, but a forced consequence of a theory with independent credentials. And abandoning the best available explanation of the vacuum's smallness because its siblings are unobservable would itself be unscientific. Nature is not obligated to make her explanations convenient. Two visions of what science is in open combat in the world's leading journal, with the cosmological constant as the battlefield. And the fight was about to get a rival. Because while the philosophers of falsifiability argued about whether the landscape was science, a physicist in Toronto had spent 2 decades quietly building the thing both sides claimed to want. A theory of varying constants that makes a prediction you can kill with a telescope. The physicist is Lee Smolin, and his proposal, cosmological natural selection, is tonight's proof that the anthropic landscape is not the only game on the board. And that the constants vary across an ensemble does not have to mean we explain them by our own existence. Smolin's mechanism borrows its logic from the most successful explanatory engines science possesses. Suppose, he proposed in 1992, that black hole interiors do not terminate in dead singularities, but bounce, each collapse birthing a new expanding region, a daughter cosmos, causally sealed behind its parent's horizon. Suppose further that each bounce slightly shuffles the constants of physics, the way reproduction shuffles genes. Then universes reproduce, with heredity and variation, and selection follows automatically. Cosmos lineages whose constants favor making many black holes leave many descendants. Lineages tuned for sterility die out. Run the dynamics for generations, and the population becomes dominated by universes whose constants sit near a maximum of black hole production. The punchline is the inversion of everything anthropic. On Smolin's picture, our constants are not explained by us at all. Observers are an accident, a side effect, because the same physics that makes abundant black holes happens to require long-lived stars, heavy elements, and cold, complex chemistry. We are pigeons nesting in a cathedral whose architecture answers to something else entirely. And the theory's crown jewel is methodological. It predicts. If our universe sits near a black hole production maximum, then no adjustment of physics should be able to increase the yield much, which forbids certain observations outright. Smolin's sharpest version. The theory of dense nuclear matter must not permit neutron stars above roughly 2 solar masses. Find a heavy enough neutron star and cosmological natural selection dies in an afternoon, in public, by measurement. For 3 decades, pulsar astronomers have been weighing neutron stars, and the heaviest confirmed masses have crept upward to brush the edge of Smolin's revised bound without cleanly crossing it. The theory lives, on death row, adjacent to its own executioner. Its standing is honestly marginal. Most cosmologists doubt the bounce, and Alexander Vilenkin argued from de Sitter physics that the black hole count can be raised in ways that break the claimed maximum. But its existence changes the debate's geometry permanently. Falsifiable rival explanations of varying constants exist. The anthropic landscape is a choice, not a necessity.
And the landscape's own house, meanwhile, harbours a rot its critics consider fatal and its advocates consider homework: the measure problem. It sounds technical. It is close to the whole ballgame. Every anthropic prediction, including Weinberg's celebrated hit, is a statement about probability. A typical observer measures a small cosmological constant, but typical requires counting, and eternal inflation produces infinitely many pockets, containing infinitely many observers of every kind, infinitely often. What fraction of an infinity is anything? The answer depends entirely on how you cut the infinity off, the measure, and different cutoffs, all seemingly reasonable, yield wildly different predictions from identical physics. Some measures predict our universe should be far younger than observed, the youngness paradox, under which the odds of a cosmos as old as ours are absurdly, exponentially small. Others predict the typical observer is not an evolved creature at all, but a Boltzmann brain, a bare, momentary consciousness fluctuating out of the vacuum with false memories, vastly outnumbering evolved minds in the count. Any measure with that consequence is held to be self-refuting, since it predicts that you, statistically, are one. The candidate measures that avoid both diseases exist, but none is derived from first principles, and switching between the survivors changes what the multiverse predicts. And before you file Boltzmann brains under abstract pathologies, notice that the argument reaches you personally and is meant to. Under a diseased measure, the typical observer with exactly your current experiences, this room, these memories, this sentence half heard, is not a person with a past but a momentary fluctuation, assembled by chance a moment ago, complete with false memories of a childhood that never occurred, dissolving back into vacuum a moment hence. How do you know you are not one? You cannot check. Every check consults memories the fluctuation would have counterfeited for free. The escape is not evidence but consistency. Any cosmological framework predicting that you probably are one has thereby predicted that your evidence for the framework is itself counterfeit. The theory soars off the branch it sits on and is discarded not as false but as self-undermining. Which is a strange and wonderful methodological moment. Cosmologists ruling out theories of the entire multiverse on the grounds that those theories make it irrational to believe anything, including those theories. Where else in science does the reliability of your own memory become a constraint on the large-scale structure of reality? Sit with what that concedes. The framework's flagship success, Weinberg's bound, was computed under one counting assumption among several, and the framework itself cannot yet say which counting is right. A theory that predicts everything with the right measure and anything with the wrong one has not yet finished becoming a theory. What does it mean when the strongest evidence for the grandest structure ever proposed depends on an arithmetic of infinities that no one knows how to do? Hold the full ledger of this chapter honestly, because it cuts in both directions, and neither camp deserves the courtroom to themselves. Against the anthropic landscape. Its subject matter is causally unreachable.
its one observable channel has yielded 4 insignificant maybes. Its probability calculus is unfinished at the foundation, and a falsifiable rival, however marginal, proves that varying constants do not force anthropic reasoning. For it, and this must be said with equal force, it remains the only framework of any kind that predicted the cosmological constant scale in advance. Its ensemble was not invented for the job, but discovered, unwanted, inside an independently motivated theory. And its central logic, observers sample only observer-compatible conditions, is not speculation but tautology, objectionable only in what it is asked to carry. The deadlock, as of tonight, is real, professional, and unresolved. But there is one more front, and it may be the decisive one, because it attacks from underneath. Every argument so far has assumed the landscape exists, that string theory really does contain those 10 to the 500 stable vacua, including at least one, ours, with a small positive cosmological constant. In 2018, a faction of string theory's own leadership advanced a conjecture that, if true, would collapse the entire edifice from within. The catalogue may be real, and our universe may not be in it. The faction calls its program the Swampland, and the metaphor is exact. Not every effective theory a physicist can write down, the program holds, can actually descend from a consistent theory of quantum gravity. The landscape is the set that can, real, buildable universes. Everything else, however sensible it looks on paper, belongs to the Swampland. Mathematics with no home in reality, theories that cannot be completed, mirages. The program's method is to hunt for the boundary, conjectured criteria separating landscape from swamp, and in June 2018, Georges Obid, Hiroshi Uguri, Lev Spodeniko and Kumran Vafa, one of string theory's most decorated architects, proposed a criterion with a detonation radius covering everything tonight has built. Their de Sitter conjecture, stated in one line of mathematics, tonight will speak rather than write. The slope of any legitimate potential energy landscape in string theory can never be too flat while its value is positive. Formally, the gradient of V must exceed a constant times V itself. Translated, a universe cannot, in consistent string theory, rest in a stable state of small positive vacuum energy. It can roll, its dark energy slowly draining, but it cannot sit. And a metastable pocket with a tiny positive cosmological constant, the KKLT construction, the landscape's load-bearing floor, the very description of the universe you are sitting in, would be forbidden. The paper's own language, quoted exactly, it has been notoriously difficult to construct a metastable de Sitter vacuum in string theory in a controlled approximation. This suggests the possibility that metastable de Sitter belongs to the Swampland. If that suggestion is right, the 10 to the 500 catalogue of habitable adjacent universes is a catalogue of mirages, and the one universe we can actually observe is not a string theory solution at all, at least not a resting one.
Why can this not simply be computed? A fair question with an instructive answer. String theory's equations are exactly solvable only in corners. High symmetry, weak coupling, special limits. A realistic vacuum with broken supersymmetry and small positive energy sits far from every corner, in territory where physicists must work with approximations layered on approximations. Expansions assumed to converge, corrections assumed small, effects assumed negligible. The KKLT recipe is a chain of such steps, each plausible, and the Swampland dispute is, at bottom, a dispute about whether the chain holds, whether the small corrections stay small or quietly grow until they dissolve the vacuum the recipe promised. Both camps run calculations. The calculations genuinely differ in regime and assumption, and no one can yet do the exact computation that would end the argument, because no one can do exact computations there at all. It is the purest example in modern science of a question that is entirely mathematical, entirely well posed, and entirely beyond current mathematics. The evidence for the suspicion is uncomfortable in exactly the way honest audits are. The KKLT recipe, 15 years a standard citation by 2018,
had never been carried to completion with every step under full mathematical control. Each ingredient plausible, the combination never rigorously certified. And critics like Savdeep Sethi arguing in detail that the construction's foundations quietly break their own approximations. That string theory's honest cosmological solutions are rolling, evolving spacetimes, not the static pocket paradise the landscape requires. The counterattack came in force. In 2024, a team led by Liam McAllister, with heavy computation and state-of-the-art control, surveyed 33,371 distinct compactifications and produced 5 candidate de Sitter vacua, the closest approach yet to an explicit, checkable entry in the landscape's habitable wing. Note both numbers, because their ratio is the state-of-the-art. 33,000 attempts, 5 candidates, and the author's own published language keeps the modesty to tonight's channel prizes. De Sitter vacua remain elusive. The candidates carry corrections whose control is an important open problem. The dispute has run hot into this year. New constructions, new no-go arguments, holographic constraints, rebuttals of rebuttals, and no verdict. Read the stakes at full width. This is no longer philosophers asking whether the multiverse is testable. This is string theory's own elite, divided over whether the theory contains our universe. If the Swampland side wins, the anthropic landscape does not merely lose its census, it loses its existence. Dark energy is not a constant, but a slow decline. And the whole selection framework built atop Weinberg's hit is homeless. If the landscape side wins, if even one of those 5 candidates survives full scrutiny, then the catalogue stands, mathematically certified, and the argument returns to the philosophers. Either way, notice who is conspicuously absent from the fight: nature. Not one item in this chapter's dispute, not the conjecture, not the counterexamples, not the 33,000 compactifications, touches an observation. The existence of the multiverse's mathematical foundation is being decided entirely inside mathematics. What does it mean that the reality of 10 to the 500 universes currently hangs on the convergence properties of a calculation? And yet, one thread from this chapter does reach the sky, and it is the thread tonight will follow out. If the Swampland faction is right that nothing can sit, that positive vacuum energy must roll and drain, then dark energy is not a cosmological constant, but a process. Quintessence, a slowly evolving field whose equation of state should deviate, if ever so slightly, from the constant's exact signature. That deviation is measurable. The current numbers from the Planck satellite and supernova compilations pin the dark energy equation of state parameter at -1.03, plus or minus 300ths, consistent with a perfect constant with just enough slack for the rollers to live in. The next generation of surveys tightens that slack decisively. There is something almost comedic and deeply fitting in where this leaves the grandest question physics has ever asked. Whether reality is one universe or 10 to the 500 may turn, in the end, on the second decimal place of a single measured number. Watch that number. It is the only place in this entire subject where the sky still gets a vote. And the sky's vote is the only one tonight's channel ultimately counts. Before the verdict, tonight must pay a debt planted an hour ago. When the KKLT construction produced a universe like ours, the load-bearing adjective was metastable. And you were told the word would return twice, once as a threat and once as a clue. Here is the threat, stated with the care it demands. Metastable means stable for now, resting in a valley of the landscape, but not in the deepest valley there is. And Coleman and DeLuccia's 1980 mathematics, the same bubble nucleation formula that delivers pocket universes, applies to any metastable vacuum, including, if the landscape picture is right, ours. Somewhere, someday, by pure quantum accident, a microscopic region of our vacuum could tunnel to a deeper entry in the catalogue, nucleating a bubble of different physics that expands at essentially the speed of light, rewriting the constants of nature as it comes, dissolving atoms, chemistry, and structure into whatever the new vacuum permits. No warning is possible even in principle. The bubble's edge travels with its own news. It is the most totalizing catastrophe physics has ever described, and tonight's channel reports it for one reason only: because the numbers that accompany it are the entire story. The same exponential suppression that makes vacuum decay possible makes it stupefyingly slow. For every candidate decay channel consistent with our vacuum's observed longevity, the expected lifetime runs to 10 raised to hundreds of years. Timescales beside which the current age of the universe, 13.8 billion years, is not even a rounding error's rounding error. The universe has already survived its full history without incident, which itself bounds the rate from above. No one should lose a minute of sleep, and everyone should notice what the possibility does to the word permanence. On the landscape picture, the laws of physics themselves are not a foundation, but a tenancy. Our constants hold not because they must, but because our valley has not yet been vacated. Even the ground rules are, in the deepest accounting, weather. Handle the fear honestly before moving on, because this topic escapes laboratories and finds people at 3 in the morning. Should vacuum decay worry you? Run the actual comparisons. The probability that our vacuum decays within your lifetime, on every serious estimate, sits so far below the probability of any mundane catastrophe that the two cannot share a chart, below the chance that a specific atom of your coffee spontaneously teleports. The low numbers language was not built to hold. The universe's own track record is the strongest testimony. 13.8 billion years across a volume of 10 to the 80 atoms without one observed transition. And there is a stranger comfort, peculiar to this catastrophe alone. It is the one disaster that cannot be experienced. The bubble arrives with its own announcement, at light speed. No observer inside its path ever registers its approach or its arrival. Whatever anxiety is for, it is not for this. The correct emotional response to metastability is not fear. It is the vertigo of the reframe. The ground rules themselves, provisional. Feel that, file it, and sleep untroubled. Now the clue, and it is the stranger of the two returns. Ask, why is our vacuum's energy so close to zero without being zero? The landscape's survivorship answer has filled tonight. But metastability adds a texture no one ordered. In the Busso-Polchinski picture, our pocket's history is a descent, a cascade of ancient vacuum decays, each step dropping the cosmological constant down the discretuum's fine staircase, until one final tunneling landed this region on a step almost, but not exactly, level with zero. On that telling, the 121.0 whisper you measure in the night sky is the residue of the last step of a staircase our region happened to stop on, with observers arising precisely because the stopping point was low enough for structure and slow enough to last. Whether that story is true is undecided with everything else tonight. But feel its texture, the most precise number in cosmology reframed as the ledger entry of an ancient, unwitnessed sequence of cosmic transitions, geology at the level of the vacuum itself. Physics has spent 4 centuries learning that the present arrangement of matter is historical. Mountains are collisions, atoms are stellar ash, the moon is debris. The landscape's most unsettling suggestion is that the present arrangement of law is historical too, that the constants in your textbook are strata, laid down by events, contingent as any canyon. What does it mean to live in a universe where even the rules might have a history? Pause on the human scale of all this before the wane begins, because there is a vertigo here the equations do not carry. Every previous demotion in science's story left something solid underfoot. Earth lost its centrality, but the sun was real. The sun proved ordinary, but the galaxy was real. The galaxy proved one among trillions, but the laws were bedrock, the same everywhere, the one non-negotiable inheritance. The landscape proposes the final demotion, the laws themselves as local circumstance, our physics one dialect among 10 to the 500, spoken in one pocket of a storm no message can cross. If the picture is wrong, physics keeps its oldest dream, one universe, one law, derivable in full. If it is right, then the deepest facts you were ever taught are provincial facts, and the true universal, the actual bedrock beneath every pocket, is a single mathematical structure, none of whose interesting details reach your sky. Either resolution rearranges what the word fundamental has meant for 400 years. That is the true size of the question tonight's verdict must weigh, and it is why the weighing must be done with none of the confidence the title of this video pretends to. Begin the weighing with what every camp accepts, because the bedrock of agreement is broader than the noise suggests. Nobody disputes the data. The universe's expansion is accelerating. Dark energy is 68% of everything. Its behavior matches a cosmological constant to 3% precision, and its measured value sits 120 orders of magnitude below the naive calculation, unexplained by any accepted mechanism. Nobody disputes the sensitivity arithmetic. The constants of physics are unfixed by known law, and the living world depends on their values through gates like the carbon resonance. And nobody disputes the phenomenon standing. The smallness of the vacuum energy is a real, quantitative, unsolved problem, arguably the unsolved problem of fundamental physics. The war is entirely about what kind of answer the problem is allowed to have. 4 candidates stood before you tonight. Here is each at its honest weight.
The anthropic landscape. For it, the only quantitatively successful advanced prediction in the field, Weinberg's window, drawn a decade before the supernovae filled it. An ensemble it did not invent, but inherited from string theory's own unwilling mathematics. A delivery mechanism, eternal inflation, grounded in cosmology's most successful early universe framework. And a logic, survivorship, that is individually unimpeachable. Against it, a subject matter its own physics renders unobservable forever, one thin CMB channel accepted, where the tally reads 4 insignificant maybes. A probability calculus, the measure, unfinished at its foundation, with paradoxes of youngness and fluctuating brains still patrolling the candidate cutoffs. And, since 2018, a mutiny in the home theory over whether the landscape's habitable wing exists at all. Standing, mainstream, dominant in cosmological practice, and epistemically contested to a degree unique among mainstream frameworks. The Swampland alternative. For it, the stubborn historical fact that no fully controlled de Sitter vacuum has ever been exhibited, decades of effort notwithstanding. Principled no-go arguments from string theory's deepest structures, and a real observational hook. If nothing can sit, dark energy rolls, and the equation of state will eventually confess. Against it, the conjecture's constant is underived, its scope disputed, and the 2024 candidate vacua, 5 survivors from 33,000 attempts, stand as explicit would-be counterexamples not yet dispatched. Standing, an active insurgency, unresolved. Cosmological natural selection. For it, genuine falsifiability, the neutron star bound, still standing, still checkable by any radio telescope. And an existence proof that ensembles do not require anthropics. Against it, an unverified bounce at its heart, and Vilenkin's argument that the claimed optimum fails. Standing, marginal, respected precisely for its methodological virtue. And the undiscovered mechanism, the quiet fourth option that the constants, and the vacuum's smallness in particular, follow from a principle not yet found. For it, the entire history of physics, which has repeatedly dissolved apparent contingency into deeper law, and the plain fact that we haven't found it has never been evidence of absence. Against it, a century of the field's best minds finding nothing, and the peculiar, suggestive shape of the one number in question, not 0, as principles produce, but 121 zeros and a residue, exactly the profile survivorship expects and symmetry cannot make. Standing, physics' sentimental favorite, indefinitely deferred. One more line must be drawn before the verdict, and tonight draws it deliberately. Nothing in this weighing, nothing in any camp's case, speaks to the oldest question this topic gets conscripted into: whether the universe's suitability for life points beyond physics. Tonight has reported the phenomenon, the frameworks, and the evidence, and it takes no position on what lies outside their reach. For the same reason, a surveyor's map takes no position on music. The instruments do not measure it. Survivorship does not disprove anything beyond physics. Narrow tolerances do not prove anything beyond physics. And every voice tonight quoted, advocate and critic alike, was doing physics, not metaphysics. Wherever your own reflections travel with this material, travel honestly. Know exactly where the measurements end. They end here. So the resolution in the 3 sentences tonight has earned the channel's full precision, no more and no less. It is established that the vacuum's energy is real, tiny, positive, and unexplained. The observation is beyond dispute, and every explanatory road from it leads through territory that is, today, unconfirmed. It is established that the only framework ever to predict that number's scale in advance is one in which our universe's constants are a local draw from an unobservable ensemble, a success that is genuine, singular, and structurally incapable, so far, of being converted into proof. And it is not established that the ensemble exists. Its mathematical foundation is under active dispute inside string theory itself. Its probability calculus is unfinished. Its one observational channel is empty. And a falsifiable rival and an undiscovered law hope both remain standing. The title of tonight's video declared the cosmos was not built for you, multiverse proof. Now you know the honest cash value of each word. That the cosmos was not arranged around your existence is the one claim every scientific camp tonight shares. Survivorship, selection, deeper law, and brute fact alike all dispense with the arranging. But proof of the multiverse is precisely what nobody has. What exists is one striking prediction, one forced and disputed catalogue, one empty sky search, and the hardest open question in physics standing exactly where Weinberg left it. The cosmos was not built for you, and no one can yet tell you what it was built by, or whether built is even the right word for whatever the vacuum did. Could anything actually settle it, map the live exits precisely, because the question deserves better than a shrug in either direction. Exit 1 belongs to the sky, the dark energy equation of state. A perfect cosmological constant holds its signature value exactly. Every rolling alternative, the quintessence the Swampland demands, drifts. The current precision, 3%, straddles the answer. The coming generation of galaxy surveys and supernova compilations will tighten the bounds several-fold within the decade. A confirmed drift would be seismic twice over. Dark energy revealed as dynamics, the landscape's static pockets in deep trouble, and, the irony of the century, the multiverse's chief mathematical rival, vindicated by the very telescopes the multiverse could never summon for itself. Exit 2 also belongs to the sky, though its odds are long, a bubble collision detection. The searches continue with each deeper microwave map. A confirmed disk with the collision profile would transform eternal inflation from framework to observation overnight. The honest prior, set by the existing bounds, is that the sky holds nothing, but the channel stays open, and it is the only one. Exit 3 belongs to the blackboard, the Swampland war resolving. A completed, fully controlled de Sitter vacuum, one of the 5 candidates surviving total scrutiny, or a successor, would certify the landscape's existence as mathematics. A proof of the de Sitter conjecture would demolish it. Either outcome could arrive in 5 years or 50. Theory keeps no schedule. Exit 4 belongs to the pulsar surveys. A neutron star confirmed safely above Smolin's bound would retire the one falsifiable rival, tightening the field by elimination. And Exit 5, always on the map, never on a timetable, is the undiscovered principle. Some future mind seeing what a century has missed, deriving the vacuum's 121-0 whisper from first principles, and collapsing tonight's entire debate into a footnote. 5 exits, 2 run through telescopes,
one through mathematics, one through radio astronomy, one through genius. The subject is not sealed. It is slow, and its openings are real. But mark, with equal honesty, the doors that are walled shut, because the walls are load-bearing for how you should hold everything tonight has said. No instrument will ever image another pocket universe. The separation is causal, not technological, and no future civilization, however advanced, breaks a horizon with engineering. No laboratory will ever reach the string scale by force. The energies sit 14 orders of magnitude beyond the greatest collider ever built, a gap no plausible technology crosses. No survey ever gets a second sky. The largest scale statistics of our cosmos are one sample, cosmic variance is a mathematical flaw, and some questions about the biggest patterns will remain forever at the mercy of a single draw. And no measurement, even in principle, seems able to distinguish the constants are a local accident from the constants follow a law we have not found, short of actually finding the law. That last wall is the deepest fact in this entire subject. The two live readings of your existence, lucky address or necessary consequence, currently generate identical observable universes. Every measurement you can name is compatible with both. What separates them tonight is not evidence but temperament. Which kind of explanation a given physicist can bear to live without? What does it mean when the most personal question physics has ever raised, why is the universe such that you are in it, turns out to sit precisely on the one boundary the scientific method cannot yet cross? Take your own temperature before the final accounting, because by this hour you have chosen a side in your chest, even if your mouth stays neutral. Perhaps the landscape thrilled you, the sheer scale, the demotion of the constants to weather, the one successful prediction gleaming. Ask yourself honestly, would it still thrill you if it is unfalsifiable forever? And would you call it science on that day? Or perhaps the deeper law hope feels like sanity, the conviction that the constants must follow from something. Ask that side too. A century of magnificent minds has found nothing. At what point does "not yet" become a creed rather than a forecast? There is no shame in either pull. There is only the discipline this channel keeps returning to, noticing which explanation you want, and remembering that the universe has never once consulted anyone's preference. Every camp in tonight's story contains physicists smarter than any of us who feel the opposite pull with equal force. That is not a scandal. That is what an honestly open question looks like from inside. It means, at minimum, this. Humility is not a courtesy here. It is the technically correct position, enforced by horizons, energy scales, and unfinished mathematics all at once. And it means the fine balance phenomenon deserves to be held the way tonight has held it, as a genuine, quantitative, unresolved scientific puzzle, not as ammunition. You will meet the carbon resonance and the vacuum's smallness deployed as proofs in every direction. Proof of a multiverse, proof of deeper necessity, proof of something more, proof of absurdity. Every such deployment outruns the evidence, and now you know exactly where each one outruns it. The multiverse's ensemble is unobservable and its mathematics disputed. The deeper law is undiscovered, and claims reaching beyond the physics in any direction are not physics at all. The equations neither contain nor exclude them, and tonight's channel, as always, asserts nothing on that question either way. The numbers are real, the narrowness is real, the explanation is open. That triple sentence is the entire defensible content of one of the most abused topics in science, and holding it without decoration is harder and rarer than any of the decorated versions. So come back to your left hand, where the night began, and look at it with everything now in place. The carbon is still there, 30-some trillion cells worth, every atom of it cooked in a red giant through the resonance Fred Hoyle ordered from existence itself in 1953. Nothing tonight has made that less astonishing. If anything, the astonishment has compounded. You now know the atom's full itinerary. Born through a nuclear gate 379 kilovolts wide, in a star burning steadily because the vacuum beneath it whispers instead of roars, in a cosmos whose expansion left matter time enough to gather. Every stage of the journey running on unexplained numbers, every number sitting within tolerances that physics can state to the decimal and justify not at all. What has changed is the size of the question the atom carries. School told you the constants behind your carbon were the laws of nature, final, universal, closed. Tonight's honest physics tells you their status is open. They are either the local weather of one pocket among 10 to the 500, or the fixed output of a principle no one has found, or facts with no reason at all. And the deepest minds alive cannot yet tell you which, because the evidence that would decide sits behind horizons, beyond colliders, and inside unfinished mathematics. You are made of the question. That is not a metaphor. The specific atoms performing your thoughts owe their existence to the exact numerical facts whose explanation is the largest open problem in fundamental physics. Whatever the answer turns out to be, it is quite literally about you. And notice what the honest version of tonight does to the title's provocation, because this is where the channel leaves you. The cosmos was not built for you. As rhetoric, it stings. As physics, both halves need surgery, and the surgery is the takeaway. Every scientific camp tonight, Anthropic, Swampland, selectionist, deeper law, agrees on the first half in one specific sense. Nothing in the equations singles you out. No term in any Lagrangian mentions observers. The appearance of a cosmos fitted to life needs no fitter on any live hypothesis. But the second half, for you, hides the real discovery of the last 40 years, which is that the relationship between you and the constants is genuinely, scientifically strange, whichever way it resolves. If the landscape is right, your existence is a filter that explains what you see, the one power the anthropic argument legitimately has. If a deeper law is right, then the universe's sole self-consistent physics happens to permit chemists, a fact that would deserve its own long night. And if brute fact is right, the question dissolves but the strangeness does not. There is no reading, none, on which your hand's carbon is boring. The multiverse does not cheapen it. Necessity would not cheapen it. Even no reason at all does not cheapen it. 14 billion years of unexplained numbers cashed themselves into a creature that can sit in the dark, hold up its own hand, and ask the universe to show its receipts. The universe has, so far, declined. The asking continues, and tonight, for 110 minutes, you were part of it. And keep one small ritual from tonight, if you keep nothing else. The next clear evening, find any star, whatever it is, a nearby dwarf, a distant giant. Its light is running on the same unexplained settings as your hand, the same vacuum whisper leaving room for its burning, the same nuclear gates minting carbon in its core for whoever comes later. You and the star are two outputs of one setting of the dials, reading each other across the dark. Nothing in tonight's physics can yet say why those dials permit the exchange. Everything in tonight's physics says the exchange is real. If these long walks to the actual edge of knowledge are something you value, consider subscribing. It helps these deep dives reach more curious minds, and the edge is not receding. The survey's tightening dark energy's second decimal are running tonight. And spare a thought for the next time you see the constants in print. A physics textbook, a formula sheet, a poster of equations sold as wall art. The speed of light, Planck's constant, the charge of the electron. They are typeset with the confidence of final truths, memorized by every student as the fixed furniture of reality. You now know their secret. Every pure number among them is an orphan, measured, not derived, obeyed, not explained, possibly local, possibly necessary, possibly neither, with the greatest theorists alive unable to tell you which. Does that diminish the textbook? This channel would argue the opposite.
A list of settled facts is a filing cabinet. A list of numbers that work perfectly and answer to nothing yet discovered is a treasure map with the destination torn off. Every constant on that poster is an open case. The students memorizing them tonight include, statistically, whoever eventually closes one. Gather the stones. A nuclear resonance at 7.65 million electron volts, predicted from the fact of chemists, confirmed within months, tolerant to a few percent, the gate every atom of your body walked through. A vacuum calculation wrong by up to 120 orders of magnitude, the worst prediction in the history of physics, beside a measured whisper of 2.8 times 10 to the minus 122, the number nothing explains. Weinberg's window, drawn in 1987 from survivorship alone, filled by 2 teams of supernova hunters in 1998, 2 orders of magnitude to spare. A catalogue of 10 to the 500 universes, forced unwanted out of string theory's foldings and fluxes, named a landscape by its own reluctant co-founder, whether we like it or not. A storm of eternal inflation to populate it, a bubble formula from 1980 to deliver it, and 4 faint maybes on the microwave sky, honestly reported, honestly insignificant, as the entire observational harvest. A measure problem that cannot yet count, a mutiny over whether the catalogue's habitable wing exists, a falsifiable rival waiting on a neutron star, and a second decimal place where the sky still gets its vote. That is the whole estate, and you hold it now with the only confidence it honestly supports. The numbers are real, the narrowness is real, the explanation is open.
Fred Hoyle deserves the final echo because his 1953 gambit contains this whole subject in miniature, and its afterglow is instructive. He aimed existence at a nucleus and hit. 70 years on, the landscape aims existence at the entire vacuum. The same weapon, scaled to everything, and no one can yet say whether it hits, because the target sits behind horizons no fowler can walk his team into. Hoyle himself, for the record, drew his own large conclusions from his resonance in later life, and his colleagues drew opposite ones from the same number. The resonance, serenely indifferent, sits at 7.65 where it always was. That is perhaps the cleanest lesson in tonight's whole estate. The numbers do not argue, only we do. The universe supplies the dials, exquisitely set and perfectly silent, and every interpretation, whether, law, chance, or more, is something human beings bring to the reading. The dials were here before the arguments. They will outlast them. One pocket, if pockets there are, among 10 to the 500. One hand, holding its borrowed carbon up to one sky. The cosmos was not built for you. On that much, every equation is silent in the same direction. But here you are anyway, the universe's own arithmetic, awake in one of its solutions, asking why the dials read what they read. No other object in the known cosmos does that. Stars burn the constants, planets obey them. Only you audit them. Whatever the landscape turns out to be, catalogue or mirage, weather or law, hold on to the one finding tonight established beyond every dispute. The universe permits its own question. It permitted you. And that, for now, for a channel that will not sell you certainty where physics has none, is the only clue anyone has.